Hello, and welcome to our webinar for Big Data Series, Apache Spark at CSC. This webinar is the first one that we are having in the Big Data Series, and there would be many more to come. So to begin with, my name is Apurv Nandan. I work at CSC in the Data Analytics Group. I have been working with Spark for the last 4 years at CSC. And the aim of this webinar is to actually provide a brief introduction about Spark, what exactly it is, and how do you deploy it on CSC's infrastructure. Since this is only the first part of our many more Spark talks to come in the Big Data series, we will only focus on what exactly is Spark and how do you deploy it. And in the next webinars, that would be coming after this, we would have the other aspects like the programming and the more advanced stuff. So to begin with, I would like to mention that we would take all the questions in the end of this webinar, and you can use the chat box to type your questions, or you can use the raise hand button on the top of the bar to, if you would like to speak your question. I think, yeah, and the presentation slides of this event would be available on this event page that you see here. So those are going to be available soon. And the video that we are going to have of this webinar is going to be uploaded at the same event page as well. With that being said, I think we should start with the webinar now. So as the title of the webinar suggests, Big Data Series, and the first one is Introduction to Apache Spark at CSC. So let's talk a bit about what is big data. So in this example, I'm presenting an e-commerce company, and what happens like in an e-commerce company on an online shopping portal is that the previous approach, what these companies used to do was that they used to analyze the transactions. So all the transactions that you do actually on the online portal, on the online shopping website, they were analyzed using the transactions that the users are making. But this is not enough, right? What happens if the transaction actually never takes place? So what would you do in that case? So this has made the world to look for new sources of data. That what could you do in that kind of scenario when the customer actually decides not to buy anything. So yeah, so the more sources of data you have to look, and some of those sources are the clickstream data, so that what kind of things that the user was clicking on the website, like what kind of products was he viewing, clicking, and reading about them. So, and then the other thing would be data from the shopping cart, like what kind of thing did he actually put in his shopping cart, but then not decided to check out. And then you can always have these kind of social networking sites at your disposal that you could see, like if a person is browsing something, that what else does he like on other social media, and what does his friends or relatives actually like. So these are some of the examples. And the last example is the more growing kind of example in big data world, is that the sensor data. So every one of us has smartphones now. And what happens is that wherever you go, for example, if you go to a restaurant or if you go to a grocery store, the next thing that Google actually asks you to review that place, that how did you find that place? So Google actually knows where you are visiting, and this kind of data is called as a sensor data, that all this data wherever you're going is being recorded. So based on the location information, you can always show the regions like where a particular product is being used more, or where the consumer is going more often. And you could recommend that kind of products from your own site if you have an e-commerce website. So this is a very tiny example of one of the cases of the big data, that what you could actually do when you have this kind of data. Of course, now since if you have this huge amount of data, you need something to process this data as well. And this is where Spark actually comes in. So if I tell you that you have to analyze a 1 gigabyte of text file, so you could use your own laptop because laptops nowadays have pretty good amount of RAM. So you would be able to analyze this just fine. No worries. But then the data actually changes to 100 gigabytes. Now you could have a very like a big PC or a server running in the cloud, and you could still maybe manage to analyze this. Or who knows, it might even crash. But the main thing is that the data actually keeps growing and growing. So in that case, consider that now you have a 10 terabyte text file. And now all the things, I mean, like all the traditional methods that you have would fail on this kind of a text file. And this is the exact thing that we are going to address in this webinar, is that you can use Spark for any amount of data. No matter how much the data actually grows, you can continue to use Spark and you can continue to analyze that data with Spark. So if it crashes, it will crash if you have a 10 terabyte text file and running on your laptop or a PC. But then if you use Spark, it won't. Before moving to Spark, let's talk a bit about cloud computing. So it's very simple. Instead of actually running stuff on your laptop, you run it in the cloud. So you run it in a remote server and you access it using your laptop. So you're actually running the stuff on a remote server kept somewhere else, and you're just seeing the output in your laptop. CSC provides this cloud computing services, and which is known as POTA, which is called as cPOTA, and the URL is actually pota.csc.fe. There's a slight error. It's called as cPOTA, but the URL is pota.csc.fe. And now, should we move to the next one? Yep. So now we are going to talk about Spark. So Spark is a fast open source big database engine, which is used for large scale data analysis that we have been talking about, and distributed processing. What distributed processing is what we are going to see in the next few slides. Spark can be used with Scala, Java, Python, or R. In the courses here given at CSC, we tend to use Python, and all the work that we do, we tend to use Python quite a lot for doing work in Spark. But it could be used with the other 3 languages as well that are listed on the screen. It works with the MapReduce concept to do the distributed processing. So what MapReduce is what we are going to see in the next few slides. And again, why should you care about Spark is because data. And then data is growing. So key concepts of Spark. So the most important feature that I think for Spark is that it tries to store the thing into memory when needed for rapid processing. As you all know that we have limited amount of RAM as compared to the hard drive. It's because if you keep anything in RAM in your memory, as we say, if you keep anything in your RAM, then reading from the RAM is much faster as reading from the disk. So the main key concept of Spark is that it tries to keep the data into memory if needed, and that allows us to process the data very quickly. And then, of course, it follows the distributed processing concepts for distributing the data across the worker/nodes of a cluster. Again, we are going to see what a cluster is and what does this distributed processing mean, or what these workers are. So as we discussed about this, the Spark API, so it means that you can use Spark in these 4 languages, and these are some of the advanced features that we are going to talk about in the next upcoming webinars, and this is beyond the scope of this introductory Spark webinar. So this is a cluster, and this is what it looks like. So every cluster would have a master and then several workers. There can be multiple masters as well, but then in a very simplistic manner, you would have one master and then typically a few workers attached to it. So a cluster is basically a set of machines grouped together, and a node is the individual machine in a cluster. So master and worker, they are both nodes in the cluster. And let's talk a bit about master now. So master is basically the entry point of the cluster. And the role of the master is to delegate requests to the worker. So whenever you do anything on your cluster, you have to connect to the master, you have to submit, you have to tell the master what exactly do you need to process. And then the master is going to send the request to the worker. And what a worker is something which carries out the processing. So the actual processing is done by the worker, but then it's the master which actually tells the workers to do the processing. So this is the key concept of a cluster, of a Spark cluster. And then a very quick slide on why should you run Spark on cloud. So the first thing is that you can request as much resource as you want, and then you can pay per usage. So if you want to add more resources or you want to delete them, it's very easy to actually do via cloud, because you can request the resources on demand and then withdraw the resources if you don't need them anymore. And you can access your Spark cluster from anywhere, because then it's running on cloud. So you just need to connect it via your laptop and then you can access it easily. And you can even share the same cluster if you have a group of people using it. So we saw how the cluster looks like. You have a master and a worker, and then we saw how why should you actually run Spark on cloud, because having this kind of a structure is much more like it's very flexible, that you can have more resource, and then it also helps you save some costs. So let's consider this when you're running Spark on cloud and scenario one. So you have a data which is like 6 GB of data. And this current configuration of cluster, that works pretty well with 6 GB of data. But what happens now is that the data suddenly increases to 9 GB. And then what happens is that the processing time is too high. And what do you do in this kind of case? You just add one more worker here. So this is the thing that allows Spark to process as much data as you want, because no matter how much the data grows, you can always grow your cluster along with it. If your data keeps on increasing, just keep on adding more workers and you should be good to go. So I had 2 workers with 6 GB of data, and now I have 3 workers which can process 9 GB of data. So in the next scenario, what happens is that my current setup is working very well with 9 GB of data, but suddenly my data has decreased back to 6 GB. Okay, sorry, there's a small typo here. This should be like 6 GB of data. So the data has decreased back to 6 GB now from 9, and the processing time hasn't changed, because you have more resources to process less amount of data. But you would need to delete the worker here. Why? Because you need to save resources and because you need to save some costs. Because if you can make your cluster work with with less amount of workers, so then you wouldn't actually need to waste the resources. So you can just take the worker down. So in this way, whenever your data increases, you add a worker, and whenever your data decreases and you think that you don't need that big of a cluster, you can always remove it down. And this is how Spark works. And this is basically what is distributed computing, that there are many workers which are actually carrying out the work for you. So what's the point of having this kind of a distributed processing that many people actually ask, like, why can't you have a large VM? VM stands for a virtual machine. A virtual machine is something which runs in cloud and that you access via your laptop. So imagine if you have a large virtual machine for the processing, and then these things happen. You realize that you don't actually need that big of a virtual machine. You can actually manage, you can do with a smaller machine. Or then you realize that you have a lot of data and you require even a bigger virtual machine. Or what happens, so this is something that always happens on cloud, that these virtual machines, for some reason, they dies all of a sudden. So this is rare, but then it happens everywhere. So what happens is that your workflow is completely destroyed if it fails. And and in the other cases as well, if you need a bigger virtual machine, then you have to let go of the smaller. If you need a bigger virtual machine, then you have to let go of the virtual machine that you have now. Or if you don't need the if you have a very big, large virtual machine, and if you don't need all of it, then what happens is that you're wasting you're paying way too much money for something that you could have actually done with less amount of money. So in this case, Spark is really, really beneficial from the cost point of view and from the growth of the growth of the resources point of view, because you can always customize your cluster. You can always grow it up and bring it back down. And yes, even if one of the workers actually fail, so if one of these actually fail here, one of the workers fail, remember the others will keep on working. So you would never lose your work no matter what, because other workers will keep on processing the stuff. So this is like one of the most important features that Spark actually provides along with others. Who uses Spark? Spark is used in a lot of companies, in a lot of across various domains in finance, e-commerce, healthcare, travel industry. Like TripAdvisor uses it, Netflix uses it, Yahoo, Alibaba. These are some of the companies that I know, and there are many, many more who are using Spark for in their day-to-day activities. Spark Stack. So what does Spark has to offer to us? So the first and the most important concept, the component is the bottom one, which is just referred to as Spark or Spark Core, the basic Spark, in which you can write anything you want. And the other components are basically components which run on top of this. So we have Spark SQL, Spark Streaming, MLlib, and Graphics. Spark SQL allows you to actually run or do analysis in Spark using SQL queries. SQL is a popular programming kind of language when it comes to dealing with relational databases. So if somebody is like more comfortable using SQL, then Spark provides this kind of component which they can use. So you don't need to know much of Python and anything. You can just start using SQL and start doing your work. And then there's something called as MLlib, the third component, which is the machine learning library of Spark. So in case if you have a machine learning algorithm, Spark provides you with ready-made libraries that you can use to do your machine learning stuff on top of Spark. And then the second component that you see is the Spark streaming. So the Spark streaming actually allows you to deal with continuous amount of data, the data that is coming all the time. We will discuss about it in a short while. Let's talk a bit about Spark programming. So this webinar is the introductory webinar. So we are not going to go deep into the programming aspects, that how do you program stuff in Spark and all, because we only have 1 hour of time and I also have to take some questions in the end. So we have divided the webinars in such a way that we are going to talk about the basics of Spark now, and then we are going to discuss about the programming aspects in detail in the upcoming webinars. So we have a Spark programming slide now coming up. So we discussed about the MapReduce paradigm, that Spark uses MapReduce to do all sorts of stuff, to run all sorts of stuff on its infrastructure. So this is a programming model which was developed by Google. And as it suggests, there are two phases for processing the data: map and reduce. Map says that you should transform each element in the data set that you have, and reduce says that you should combine the data according to some criteria. And the last point I would say is that Spark is actually using this thing to continue its distributed processing. Let's have a look at what map and reduce actually look visually. So suppose you have a data set. I mean, this is like a very, very trivial toy data set because this is a toy example. So if you have a data set like this, and I tell you to do a map operation in Spark, you apply a map like this, And you have, when you are doing the map, remember that it transforms all the elements in the data set according to some criteria. So the criteria that I'm providing now is that I'm telling it to multiply each element by 2. So after applying the map, you can see that each element has been multiplied with 2. So 1 becomes 2, 2 becomes 4, 3 becomes 6, and so on. And then the second phase in MapReduce was reduce, which says that you have to combine the data according to some criteria. So I use a reduce like this. And I say that the criteria for my reduce is that I should be adding all the stuff together, all the elements together, and that yields me a value of 30. Because if you count all those elements like 2 plus 4 plus 6 plus 8 plus 10, that leads up to 30. So this is how you do a map and reduce, and this is what Spark uses. So this is very different from the regular programming language that you would have seen. This works on primarily on this concept of map and reduce, which was very popular from this functional programming paradigm. So this is how you program in Spark. And then we have to talk a bit about machine learning. So machine learning in Spark is done by using this MLlib library, which is Spark's native machine learning library. So instead of actually typing the code yourself, what you could do is that you can use the machine learning library of Spark that it has to offer. So there are many libraries that Spark already gives you, such as the ones that are listed here in this list. The main point of using this library is that they have been designed by experts and they are well tested. So instead of actually coding your own machine learning algorithm, if you think that you have a requirement where you need to use, for example, k-means clustering algorithm, you can use the one that Spark has to offer. And this is now very different from something that you use with, for example, scikit-learn, which is a very popular machine learning library, because scikit-learn runs on your machine, on your laptop, or on a machine wherever you run it. But then this machine learning library of Spark is actually running in Spark. And the main point of running in Spark is that Spark is running across a cluster. So again, the same benefits. You can add a worker, you can delete a worker, you can increase the size of the cluster, or you can decrease the size of the cluster. This is something which is not achievable by using a simple scikit-learn, for example. So this is Spark's dedicated machine learning library, and this allows you to run stuff on Spark, which runs in a distributed fashion, and which allows you to actually process big, large, huge amounts of data, however you want to put it. So this being done, there is another friendly reminder that there are SQL queries that can run on Spark. So if any one of you is like very well versed with this SQL programming language, dealing with databases, then they are very welcome to actually use Spark using SQL queries itself. And then Spark streaming. Let's talk a bit about Spark streaming. So normally how Spark runs is that it runs on demand. So whenever you tell Spark that now is the time for you to run, it's just going to run. But then in case of Spark streaming, it runs continuously after a fixed interval of time. So in this case, what happens in Spark streaming is that if you define that it has to run after every 10 seconds or something, then it's going to automatically run after every 10 seconds until you stop it. It is very, very useful in case where the data is not static and it's coming 24/7. So for example, a lot of research that we do, like the traditional way, is that we have our data in some format, in text format, or maybe in some other format, and that is a file that you keep somewhere, and then you use it to analyze stuff. But in case of Spark streaming, the data is so huge that you can't actually afford it to keep it in a storage, because the data, and it's coming all the time. So for example, in case of a in case of the e-commerce website that we saw, all the time users are going there, clicking on a product, viewing a product, and this kind of data is being fed to Spark continuously. So what Spark does is that it tries to analyze this data, that which product are you looking at, which product are you clicking, and then it tries to process and analyze the data on the go. So the data is coming 24/7 and Spark runs continuously until you stop it. And this component of Spark is known as Spark streaming. Okay, before we see how do you write code on Spark and how do you deal stuff. So we discussed about that we write the code in MapReduce paradigm, or we use this MLlib library, or we use Spark streaming, but we didn't actually see how do we type the code to Spark. How does the Spark know that where is my code and what code does it have to use? So I think you might have heard about Jupyter Notebooks. It's a very popular open source web application that we use for data analysis. And it supports many languages, and the most popular ones are Python, R, Scala, or Julia. And the output that you get is very interactive, and you get it in the web browser. And it's very good for demo and learning purposes. It's very easy for sharing your work. You can download and share it with others. And the most important feature of this Jupyter Notebooks is that it integrates well with Spark. So the point is that you write your code in Jupyter and you get the output. So traditionally what people do is that they write their code on their laptop which has Jupyter running. So if you write your code in Python in Jupyter that is running in your laptop, so you provide an input and your code runs and then you get the output. But in this case, what happens is that you have a Spark cluster and you run Jupyter on top of your Spark cluster. So instead of running it in a laptop, you're running the Jupyter on your Spark cluster. So, and the other things remain the same. The code remains the same, the input comes, and then you get the output. The only thing that changes is that you're running the stuff on your Spark cluster. I think, yeah. So this is what Jupyter is, and you use Jupyter for writing code on Spark. Now, we come to the point where we are talking about deploying a Spark cluster at CSC via Rahti. So CSC has this very nice service, in-house service, which is called as Rahti, and this is CSC's in-house container cloud. And Spark right now runs on top of Rahti. The web page for Rahti is rahti.csc.fi. And the only thing that you have to note is that you need to have access to Rahti. So even if you have a CSC account, you still need to have access to Rahti to be able to run Spark. So how do you run? I mean, like, what are the prerequisites? So you should get a CSC account if you don't have one. Then you should ask for Rahti access via Rahti support at csc.fi. And then you should select Apache Spark from the catalog and follow the instructions there. And what does it look like? So I'm going to go now to the console. This is rahti.csc.fi. And then it opens this kind of a window. Now you have to click on this Rahti web user interface that opens this kind of login screen. So if I click on this, so it opens this kind of a console, and then you have to click on CSC account where it asks for your credentials. And you enter your credentials and click on login. And then you get inside Rahti. And this is how Rahti actually looks like. This is the dashboard of the Rahti. And can you see the small yellow elephant over there? And that's Apache Spark. And this is the icon that you have to select from the catalog, and then you have to run it. So if I click on this, it says that it gives me some information that what Spark is, and what does it do. And there's also a documentation for advanced users. So one of the webinars that we have planned in the future is going to focus on advanced features of this deployment. So basically in this webinar, we are just going to deploy using the default values. But in the future, we are going to show how you could actually play around and have like more complex features in this deployment. There's the documentation that we use for this deployment. So if anyone of you is like really interested and is going to have more complex features and complex requirements, I recommend you to read this documentation and then carry on with the deployment. So this is how it looks like. I click on next, then it says that add to a project. So in order to deploy Spark, you need to have a project in Rahti. So I'm just going to go and create a project. I'm just going to call it my name, Spark. Again, my name, Spark. I'm going to call my cluster as my name, Spark cluster. And then, so this is the project for Rahti, and now this is the name of the cluster. So this has to be a unique identifier for a cluster, and the recommended value is your username. So whatever your username is, you put it there, and then you put something else like Spark or Spark cluster. And then you put username. Please remember, do not put your Rahti username and password here. It says that create a new username for logging into the Spark UI and Jupyter. And similarly for the password. So for now, I'm just going to put demo, and then the password is also demo. Never put the password that you're actually using it in your email or something else, because then it shows up here. It doesn't have a password field. And I know that's like a pity, but still, just be careful. If you're like trying to explain it to others after this webinar, don't try to put in your own password there. So, and then it says that how many workers do you need to have? So by default, it says that it will give you 4 workers, and that is good enough for me. And then the storage size, that how much storage do you require? And then there are like other configuration values that we are not going to actually touch right now. We are going to go with the default value of the CPU and the RAM, or memory as we call it, and we are just going to go forward and create it. So it says that Apache Spark is being provisioned in my name Spark project of Rahti, and this may take several minutes. I close it. I see that I have a Rahti project over there. I click on it, and I see that my deployment is running. So Spark is being created. Spark is being deployed right now there. And it may take a few minutes or a few seconds. So yes, it's almost there, almost there. Come on. Okay, so now it shows that it has deployed everything clearly. So remember, you need a Spark cluster, and then you need a Jupyter notebook to write stuff on your cluster. So one of the URL is this that I can see over here. And this is, when I open it, it says that it requires your username and password. Again, this username is the one that you gave when you created this Spark cluster. So in this case, it was demo, and I click on OK, and then I have my Jupyter here. But where's the Spark? So to locate Spark, I have to go, to locate the URL, I have to go to here, and you see the URL over here. So you have to, and then it again requires for the password. The password is again the same. So your name, Spark cluster, and then the master has the URL for the Spark UI, for the Spark user interface. And the Jupyter deployment would have the URL for the Jupyter notebook. So you need to have a Spark web UI where you can see how your Spark cluster looks like what's the configuration of the Spark cluster. And then you need to have a Jupyter notebook where you can actually type some code and run it in your Jupyter. Sorry, across Spark. So if I select Python 3, and then I try to run some stuff, so I'll just say that. So again, this is not a programming course, so I'm just going to write the Spark code itself. But we are not, like, the explanation of the code is beyond the scope of this webinar. So I'm just going to write some sample Spark code. So this is so this is how you actually start Spark, by creating a Spark context. We are going to discuss more in the programming webinar for Spark, and then this is how I run a sample code on Spark. Okay, please don't fail. So if I go here in the master, I press F5, and then now it says that it's running. This code is running here. And this is my PySpark shell, the name of the application. You can always customize the name of the application, but by default, it assumes whatever you run on Jupyter, the name of the app would always be this PySpark shell, which you can customize for your own work. So it says that you have now one running application, and this is the output. And this is basically how you actually run stuff on your Spark cluster through Jupyter. You deploy it through Rathi, and then you try to run stuff using Jupyter after deployment. So go ahead, and I'm going to kill this job now. And once I kill this, so this dies. So whatever you type now is not going to run on Spark, because I have killed that job. So this is done, but now the most important thing is that what happens if my data actually grows quite a lot. So the same things that we were talking about Spark, what is the benefit of Spark now? So as you can see, it says that there are like 4 pods or 4 workers, as we actually mentioned while creating this cluster that we created, that we went with the default configuration of having 4 workers. So this is the figure that it basically shows me, 4 pods or 4 workers. Don't worry about the term pods. This is something that is very specific to Rathi, but then we are going to just call it 4 workers. I'm going to actually, so there's a question that says that we were wondering, how does one load a data set? So in order to load a data set, typically what you need to do is that you need to get the data. So for example, if I open a terminal just for demo purposes, so Jupyter also gives you a very nice terminal, and then you need to load the data here. Like, you can just put it on any website, and then you can just use the wget to download the data here, or you can always use this file and try to oh, sorry, where is that? Or you can use this upload button to upload stuff into Jupyter if it's like very small file. So if you click on this upload, it's going to upload the stuff here into this Jupyter, and then you can continue using that kind of stuff. And yes, it's a shared. So again, the user is asking me that, is this a shared file system on all the nodes? Exactly, this is a shared file system on all the nodes. And as I previously mentioned, that if you want to read more about these things, like more complex features of loading the data set and doing more stuff, when you click on this catalog, there was this view documentation And then this documentation is actually tells you more in details. So yes, to answer your question, this is the file shared file system on all the nodes. All the workers can actually see that file if you put it there. And this is by default that you don't have to do anything. Just put your file in that file system and then it will continue to fetch it. So this is the documentation that it says, that it explains you what kind of things that you have. And if you want to add more storage, you can just add more storage by following this documentation. So this is a shared file system. Very good question. And whatever you put in this file system, so for example, I created a file here, is going to be visible here. So, and this is something that Jupyter can read, and all the workers can read. So this is so once your Spark workers are reading it from a shared file system, it should be you should be good to go and load the dataset. Right. I was going to show you something else now. So let me close this. Yeah. So the main point of Spark was to actually scale up and scale down, like add more workers and delete workers as per your own flexibility and requirement. So for example, if I think that I need to actually increase the number of workers, so I just click on this arrow, and this wonderful feature that Rathi offers just scales the cluster up. So now it says that you have 5 workers. How do I know that it's not lying? I just go and press F5. Can you see one more worker appearing here? So now it says that you have total 15 gigabyte of memory, because each worker offers you 3 gigabyte of memory and 2 cores. So 5 workers is like 3 into 5 is like 15 gigabyte. So effectively you are now looking at 15 gigabyte of usable memory and 10 cores. So this is something that will keep on growing, like if you want it to grow as per your data set, and you would never run short of the memory that you would have, because you just keep on growing all the time. Okay, there is another. Okay, so there is one more question asking me that does it work with the data? So does it work with data located on CSC? Yeah. Or do we have to copy them? So you in this case, you have to copy them in Spark, because this is a separate deployment and you have to copy them in Spark. But there is CSC now offers a service which is called as POTA object storage. So if you put your file in object storage that CPOTA offers you, Spark is able to read from that. So even if you typically you would need to get this data into your Spark in this shared location, and otherwise you can also read it from CPOTA object storage if you manage to put the data there. We are trying to have more modes of retrieving the data, that even if it's we're trying to see what we can do if it's put on other CSC services like Taito and all. But since this is something very new, Rathi and Spark on Rathi itself, so we are adding more features gradually from time to time. Right. So this is how you scale up the clusters. So now we have 15 gigabyte of memory. If you want to add more, you can again go click there, and then it says that now it's scaling to 6. And then I just press an F5. So I was effectively having 15 gigabyte of memory, and now I have 18 gigabyte of memory. Right, so this is how this works. So this was just the introduction, that how do you deploy it? How do you make it run? This is like just for trial purposes. A lot of people would have like more advanced kind of questions. So we are going to, you can always email us if you have any kind of Spark related questions at servicedesk@csc.free. We would be really happy to help you in your use case. Uh, but the scope of this webinar is beyond like discussing about more complex features. So this was just the introduction showing you what Spark is and how do you deploy a very small cluster on CSC's infrastructure. There are many more complex features that installing your own libraries that is put in this documentation that we have. So because there are always like these kind of libraries that you require for running stuff on top of Spark, because Spark doesn't have because by default Spark wouldn't have the kind of libraries that you're looking for. So this is the kind of stuff that we discuss in the courses offer here at CSC, which is like a 2-day course, because these kind of things take quite a bit of time to discuss. And right now we have planned these advanced features to be discussed in the upcoming advanced Spark webinars. What else did I have? Yeah, okay, so I have one more thing to mention. So we discussed how do you deploy a Spark cluster at CSC via Rahti, right? So in this case, you need to get a CSC account and then ask for Rahti access and then like the things that we just saw. Right, and then the main thing is the more appealing thing to everyone is this notebooks.csc.fee. I think I don't know how many of you are familiar with this. This is a very amazing service that CSC has to offer, and so there are very nice and hardworking people working behind this service, like me, and so this is something that you can use even with your Haka accounts. So notebooks.csc.fee is a service that allows you to that gives you environments for working with data analysis and programming. It's used quite a lot extensively nowadays for training, learning, demos. Like a lot of universities are using it for a lot of courses in machine learning and programming, or yeah, and other genres as well, I think. And the most important feature of notebooks is that you can log in using your Haka account. You don't even need a CSC account to use this notebooks.csc.fee. From starting next month, early next month, it would be possible to launch small Spark clusters via CSC notebooks for learning or testing purposes. So the notebooks is going to allow you to launch Spark clusters via your Haka account just by logging there and clicking the button. But but it won't allow you to create large amount of clusters from notebooks.csc.fee because it's a free service. So we can only offer like a tiny bit of cake to everyone. So, but if you want to have a large cluster, if you really have a use case for your own work, you just have to get a CSC account. You just have to get access for Rahti and launch Spark, and you can create as big of a cluster as you want. So Rahti and notebooks, these are the two things that you could use for deploying the Spark cluster at CSC. And with this thing, I come to the end of the presentation. Now, if you have any doubts, you can raise your hand and speak, or you can type your questions in the chat. And yes, one more thing is that we would very much appreciate your feedback. So if you liked this webinar, or if you want more advanced webinars concerning like according to your own wishes, please fill the feedback and provide what exactly you would like us to speak next. We have quite a lot of topics coming up in Spark regarding the programming part, and then configuring the cluster for more powerful operations and storage, and then working with custom libraries. So these are some of the things that we are looking to actually continue. So you can always mention these things in the feedback, that what is the thing that appeals you most in the next webinar that we are planning to have. So please put in a feedback if you like the presentation. And as always, if you need any kind of assistance with Spark in your use case, you are very welcome to email us at servicedesk@csc.fee. So this webinar that is recorded would be going to the event web page. So this web page that you have, Big Data Series, Apache Spark CSC introduction, the slides would be here, and then the recorded webinar link would be here as well. And speaking of webinars, I've been told to mention that you can go and see other trainings and other webinars that CSC is offering uh, after this Spark webinar. So there is one coming in March, and then there are many more coming after that. Oh, at least in April there are two. So this is the list of webinars, upcoming webinars at CSC. You can go and check at the CSC's training. CSC's training site that is mentioned in the chat now, and you can find all the past webinars on the YouTube channel, like including this one, and the link is there. Sorry, so I have a question which says that, is there any practical session? Could you please elaborate? What kind of practical session are we talking about here? And then I have a question which says that, can you use Spark for performing mathematical operation, example, matrix algebra that requires huge amount of memory, like example, more than 1.5 terabyte? The answer to that, as I have been mentioning, that there is no limit to how much memory can you have in Spark. If you have the billing units, if you have the money, you just buy the resources from Rathi, and then you can continue to add as much memory as you want. But there is one disclaimer that comes with Spark, is that it is very different from a traditional programming language. It uses MapReduce paradigm. So you have to code according to Spark in map and reduce, using map and reduce operations only. Your normal code is not going to work here. So everything that you do has to be coded in terms of like in Spark world. So any other questions? I don't understand what is a practical session, but then I mean, if you're talking about that, I'm going to show you like how do you run something on, like run some complex use case. For biologists with limited amount of computer science. Well, in this case, I would say that, so are you talking about bioinformatics now, right? Somewhat. Okay, so there are many, yes, there are many libraries that are designed for bioinformatics itself. If you like, one of them is like Adam, and then other is like Hail. So if you get in touch with service desk at csc.fi, we have like people who have worked, who have tried using libraries on Spark, bioinformatics libraries, but uh, one of them I can show you, like Spark. This is the most famous one. So this is like one of the libraries in bioinformatics that is run for Spark. So that's the whole point of Spark, because programming in Spark could be a little tricky. So what happens is that the open source community in different domains offer you predefined like ready-made libraries that you can use. So in case of bioinformatics, one of those libraries is this Adam. And this is a very popular one, and uh, I think, yeah, a lot of people actually tend to use this. And then if you're using Spark, you don't actually have to reinvent the wheel. As I spoke in this MLlib library, this machine learning library of Spark, that you don't, if you think that there is a machine learning algorithm that exists already, you should use that. Similarly is the case with bioinformatics or geoinformatics or any other science field, that you can just search for that particular library and run on top of Spark. If there are no further questions, then I thank you all for attending this webinar. And as we look forward to having you in our next set of webinars in this big data series, where we discuss more in depth about Spark and doing more sorts of complex things with Spark. So thank you once more, and hope to see you soon.